Welcome to the world of JavaScript while loops. In this video, we will be mastering the art of iteration control. While loops are fundamental control structures that execute a block of code repeatedly, while a specified condition is true. They provide a flexible way to create iterations based on dynamic conditions. The basic syntax of a while loop is as follows: the keyword while, followed by a condition in parenthesis, and then a code block within curly braces. The code inside the block will be executed repeatedly, as long as the condition remains true. It is also necessary to update the condition within the loop to avoid infinite loops. Let's look at some basic examples of while loops. First, we have a counter example that counts down from 5 to 1. Here we initialize a variable count to 5, and the while loop continues as long as count is greater than 0. Inside the loop we print the value of count, and then decrement it by 1 using count minus minus. This will print the numbers 5, 4, 3, 2, and 1. The output shows decreasing numbers until the condition becomes false. Next, let's consider a sum calculator. Here we'll calculate the sum of numbers from 1 to n, where n is 5. We initialize n to 5, sum to 0, and I to 1. The while loop continues as long as I is less than or equal to n. Inside the loop we add the value of I to sum, and then increment I by 1 using I++. This demonstrates the accumulator pattern with a while loop, and the final sum would be 15. Now let's explore the do-while loops. Do-while loops are similar to while loops, but with a key difference. They execute the code block at least once before checking the condition. Here's a comparison between while and do-while loops. In a while loop, the condition is checked first, and the code block may never execute if the condition is false from the start. The code would look like this: while parenthesis condition closing parenthesis curly brace, the code which may never execute closing curly brace. In contrast, a do-while loop executes the code block first, and then checks the condition. Therefore, it always executes at least once. The code would look like this: do curly brace code that always executes at least once closing curly brace while parenthesis condition closing parenthesis. Let's look at a practical example. User input validation. We can use a do-while loop to continuously prompt a user for input until a valid input is received. The do block will execute at least once, even if the input is valid from the beginning, ensuring the prompt is shown. Let's explore common condition patterns used with while loops. The first pattern is the boolean flag pattern. This uses a boolean variable to control loop execution. We initialize a boolean variable is running to true, and the while loop continues as long as is running is true. Inside the loop we can process something, and if a certain condition is met, we set is running to false, terminating the loop. This pattern is ideal for event-based or user-controlled loops. The second common pattern is the search pattern. This pattern continues until a specific value is found. Here we initialize found to false and an index to 0. The while loop continues as long as found is false, and the index is less than the length of an array. Inside the loop, if we find our target value, we set found to true and the loop terminates. This pattern is commonly used in search algorithms and data processing. Now let's talk about infinite loops. These are loops that never terminate due to errors in the condition logic. A common cause is an incorrect condition. For example, the loop while true will run forever. Another example is forgetting to update the counter, like in the loop where count is less than 10, but we are missing the count ++. Here are some warning signs of infinite loops. The condition never becomes false, missing increment or decrement of a counter, and the browser or the program freezing. To prevent infinite loops, we can add safety measures like adding iteration limits, double-checking the condition logic, ensuring that the counter is updated, and testing edge cases. In this example, we use max iterations as a safety counter for how many times a loop can run. Now let's discuss breaking conditions in while loops. The break statement immediately exits the loop when a condition is met. For example, inside a while true loop, if a certain condition is met, the break statement will terminate the loop. Similarly, if an error occurs, we can use break to exit the loop. Use the break statement when you need to exit the loop entirely based on a condition. The continue statement, on the other hand, skips the rest of the current iteration and continues with the next. For example, in a while loop, if we want to skip a particular item, the continue statement can be used to jump to the next iteration and skip the remaining code for the current iteration. Use continue to skip specific iterations while maintaining the loop. Let's look at some practical use cases for while loops. One common use case is an API retry mechanism. Here we implement a retry logic for failed API requests with exponential backoff. We initialize max retries to 3, retries to 0, and success to false. The while loop continues as long as success is false and retries is less than max retries. Inside the loop, we try to fetch the data, and if successful, success will be true and the loop terminates. If there is an error, we increment the retries and wait a specific amount of time calculated using exponential backoff. This gracefully handles temporary network issues. Another example is a game loop. Here we have a main game loop for handling continuous updates and rendering. The game will continue to run as long as game running is true, handling the input, updating the game state, and rendering on the screen. If game over is detected, the game running will be set to false, and the game loop will terminate. This is a common pattern in game development for continuous execution. Finally, let's review some best practices for using while loops. First, let's look at some do's. Always include a clear exit condition that will eventually be met. Make sure you update loop variables within the loop body. Also use for loops when the iteration count is known. Here is an example of good practice. We initialize a retry count to 0 and the max retries to 3. The while loop continues as long as retry count is less than max retries. Inside the loop, we increment retry count using retry count ++. Now let's look at some don'ts. Avoid complex conditions that are hard to understand or maintain. Don't modify loop variables in multiple places within the loop. And finally, never rely on floating point numbers for loop termination. In this example, the loop may never terminate because of the floating point precision. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.